Question about a text problem in which we had the function g of x equals x cubed plus 3 to the x. We were to do two things, and the first was to sketch a graph of g of x and determine if it seems like it has an inverse, or actually determine if it in fact has an inverse. We first begin by graphing the x cubed function, and we graph that in red here. And we graph the 3 to the x function, that's in purple. We note that both the x cubed and the 3 to the x function are strictly increasing. Every time x increases, y increases. So when we add the two increasing functions, we're clearly going to get an increasing function. The function that we get is represented in green here. Now, to get a point of the green graph, we add the y-coordinate of the purple graph, which corresponds to a height, to the y-coordinate or height of the red graph, the x cubed graph. So we're adding the y, the value of 3 to the x, to the y here, the value of x cubed. Since 3 to the x is a small positive number, it's going to increase x cubed by a small positive number, so that the green graph of x cubed plus 3 to the x is going to lie a little bit above x cubed. As 3 to the x gets bigger and bigger, the green graph will lie correspondingly further and further above the red graph, because when we add the y value here to the y value here, it's going to have that effect. Naturally, we can continue, and the green graph will always lie a distance above whichever graph we want to look at by the height of the other graph. And from that idea, we can fairly easily get a good graph, and we see that this graph will succeed with the horizontal line test. That is, any horizontal line is going to intersect this green graph at one and only one point. Now, the next question involves the inverse function. If we take a value y and project across to the green graph and down, we get g inverse of y. Because if this was x and this is y, to get the inverse function, as you know, we would switch the roles of x and y, so that x would appear on this axis and y on this axis for the inverse function. So if we take a y value here, project over to the graph and down, we get the inverse function for that y value. Now, the statement of the problem in the text is, find g inverse of x when x is 20. I'm sorry, this is the intention of the question in the text. The text says find the value of the inverse function for x equals 20. And it's not clear from that whether we're talking about the x of the original function, this x, or the x of the inverse function. But it will clarify that by saying we're finding the x of the inverse function. We wouldn't be talking about approximation if we were talking about x on the original function, because we could simply substitute x in and get a value. Okay, we can't solve this. It's not just that we don't know enough, we know that we'll never know enough to solve this in the sense of writing down some formula for x in terms of y. Can't be done. So what we do is we approximate the solution of the equation. Okay, when x equals 20, what's g inverse of x? Well, you know that when you turn this around, you're going to want the x value such that this function equals 20. And we can solve this by approximating. If x is 1, we get 1 plus 3 is 4. If x is 2, we get 8 plus 9 is 17. We're getting close to 20. So x is going to be a little bit over 2. And we can refine that estimate as much as we need to.